Australia is home to some of the world's richest mineral deposits: gold, iron ore, rare earths, minerals that power economies and shape nations. But hidden among these giants is something far rarer, a mineral so unusual that, despite decades of searching, it has never been confirmed outside of Australia. A bright green nickel mineral born from the slow destruction of an ancient ore body, a mineral discovered in one of the most remote parts of the Pilbara, and a mineral that helped reveal an entirely new branch of nickel chemistry. This is the story of Nullaginite. When most people think of rare minerals, they imagine glittering gemstones hidden deep within mountain ranges or exotic crystals growing inside volcanic cavities. Nullaginite is different. It is not famous. Most people, including many geologists, have never heard of it. Yet this obscure mineral may be one of the rarest geological substances ever discovered in Australia. Its story begins in the remote Pilbara region of Western Australia. Today, the Pilbara is known around the world for its vast iron ore deposits. Gigantic mines carve into ancient rocks that formed billions of years ago. Trains stretching for kilometres transport ore to ports along the coast. The region has become one of the world's great mining provinces. But iron ore is only part of the story. Scattered throughout the Pilbara are deposits containing nickel. Nickel is an important industrial metal. It is used in stainless steel, batteries, alloys, and countless modern technologies. Most nickel deposits form deep underground where hot magmas concentrate nickel-bearing minerals. Over millions of years, these deposits may become buried, uplifted, weathered, and altered. The deposit that would eventually produce Nullaginite followed exactly this path. Near the town of Nullagine lies the Otway Nickel Deposit. At first glance, it is not especially impressive. It lacks the enormous scale of Australia's major mines, and the spectacular mineral specimens that attract collectors. Yet hidden deep within its weathered rocks was a mineralogical treasure. The original nickel minerals formed deep underground. These minerals contain nickel locked within sulfides. For countless millions of years they remained stable. Then, everything changed. Australia is one of the oldest continents on Earth. Many parts of the Pilbara have remained above sea level for immense spans of geological time. Instead of being repeatedly buried and uplifted like younger mountain belts, these rocks were exposed to weathering. Rainwater slowly penetrated fractures. Oxygen entered the system. Groundwater began attacking the original nickel minerals. What followed was a long chemical transformation. Nickel was released into solution, sulfides broke down, new minerals began to form. Geologists call this process supergene alteration. It is one of the most important mechanisms in economic geology. Entire ore deposits can be transformed by weathering. New minerals appear, old minerals disappear, and metal can be concentrated or redistributed. At the Otway deposit, this process produced an astonishing collection of unusual nickel minerals. Among them was something nobody had seen before. The mineral appeared as green nodules, coatings, and veinlets. It did not match any known species. Its chemistry was different, as was its crystal structure. It represented something entirely new. During the late 1970s, mineralogists studied the material in detail. Laboratory analysis revealed that the mineral consisted primarily of nickel combined with carbonate and hydroxide. The results confirmed what researchers had begun to suspect. This was a completely new mineral species. In 1978, the mineral was officially recognised. It was named Nullaginite after the nearby district of Nullagine. For most discoveries, this would be the end of the story. A new mineral receives a name, collectors seek specimens, and researchers publish papers. Eventually, the mineral is discovered elsewhere. Many minerals first identified in one location are later found across the globe. Nullaginite appears to be different. Decades have passed since it was discovered. Geologists have explored nickel deposits across multiple continents. Mineralogists have examined weathered ore systems in detail. Yet Nullaginite remains extraordinarily elusive. As far as current records indicate, all confirmed occurrences remain Australian. That alone makes it remarkable. To understand why, we need to look at how Nullaginite forms. Most minerals require specific conditions. Quartz needs silica-rich fluids. Diamonds require extreme pressures. Gold often requires hydrothermal systems. Nullaginite requires an unusually narrow set of circumstances. First, there must be a source of nickel, and not just traces of it, but large concentrations. Second, a nickel-bearing mineral must be exposed to weathering. And third, groundwater chemistry must be just right. Carbonate ions must be available. Acidity must remain within a suitable range. Water movement must be slow enough for the mineral to precipitate rather than being washed away. Finally, these conditions must persist for long periods. Change any part of the equation and different minerals form instead. This is one reason Nullaginite is so rare. Nature has very few opportunities to create it. The Otway deposit happened to provide exactly the right conditions. In fact, the deposit proved so unusual that Nullaginite was not the only new mineral discovered there. Researchers also identified Otwayite, then Otwayite. 3 new minerals from a single deposit. For mineralogists, this is extraordinary. Most mines never produce a single mineral new to science. The Otway deposit produced several. The reason lies in the unusual chemistry of weathering nickel ores. When nickel is released from primary minerals, it can combine with numerous elements: sulfur, carbonate, silica, hydroxide. Each new combination creates different minerals. Tiny changes in groundwater chemistry can completely alter the outcome. The Otway system appears to have occupied a very unusual chemical window. It became a natural laboratory where rare nickel minerals evolved. One way to think about it is as geological evolution. Just as biological evolution produces rare species under unusual environmental conditions, geological processes can produce rare minerals under unusual chemical conditions. Nullaginite is one of those geological species, a mineralogical oddity that emerged because an ancient ore body experienced exactly the right sequence of events. The rarity becomes even more impressive when you consider the scale of exploration. Nickel deposits occur across Australia, Canada, Russia, Finland, South Africa, Brazil, and many other regions. Thousands of geologists have examined them, countless samples have been collected, yet Nullaginite remains almost unknown outside Australia. That rarity gives the mineral scientific importance far beyond its economic value. No company is going to build a mine for Nullaginite. No industrial process depends on it. Its significance lies elsewhere. Rare minerals provide clues about geological environments. They act as fingerprints. When geologists discover a mineral, they can work backwards to reconstruct the conditions that created it. Temperature, pressure, fluid chemistry, weathering history. Nullaginite records a very specific chapter in the life of a nickel deposit. It tells us that nickel-rich minerals were altered by oxygenated groundwater, that carbonate-rich fluids were present, and that the chemistry remained stable long enough for rare minerals to crystallize. In this way, Nullaginite becomes a geological detective story. A small green mineral preserving evidence of processes that unfolded over millions of years. There is also something uniquely Australian about its existence. Australia's geological history is unusual. Large parts of the continent have remained tectonically stable for immense periods. Weathering has operated for tens of millions of years. Ancient landscapes have survived. Old mineral deposits have been exposed to prolonged chemical alteration. These conditions create opportunities for unusual secondary minerals to form. Many countries possess nickel deposits. Few possess Australia's combination of age, stability, and weathering history. That may help explain why Nullaginite remains so strongly associated with Australia. It is not simply a product of nickel, it is a product of Australian geology. Today, specimens of Nullaginite are sought by specialised collectors and museums. Most people will never see one. Even among mineral enthusiasts, it remains obscure. Yet that obscurity is part of what makes it fascinating. In a world where major discoveries often involve giant deposits, critical minerals, and billion-dollar projects, Nullaginite reminds us that geology still contains mysteries at every scale. Sometimes the most remarkable discoveries are not measured in tons. Sometimes they fit in the palm of your hand. A small green mineral, found in a remote corner of Western Australia, born from the slow weathering of an ancient nickel deposit, and after decades of searching, still known only from Australia. For now, at least. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.